live on a restless, ever-changing planet, a world that supports life, yet also a place full of dangers. Hundreds of millions of people are affected by natural disasters and extreme events every year.
Why does a storm suddenly take off? That's a really big question.
Because of the size of the Japan earthquake, the axis of the Earth actually moved and it changed the length of the day.
So in the western U.S., this loss of fresh water supply will certainly impact our quality of life.
To help answer these questions, scientists and engineers at NASA's Jet Propulsion Laboratory are conducting research, building and testing instruments, and analyzing data. California's Central Valley is one of the world's most productive agricultural regions. It has always been rich with water. In contrast, the dense population of the Los Angeles region has become dependent on imported water. Take the water away, and instead of 16 million people, this area could sustain less than 500,000. Where does most of this water come from? Snowmelt from the Sierra Nevadas and Colorado Rockies.
The water supply that's brought in the aqueducts, about 75% of that water comes from snowmelt. So there's a natural handoff of water. When the human-made reservoirs release water, it's at about the same time that snowmelt is coming in. The mountain snowpack is melting earlier in the year for different reasons in different places. And that water that used to come in as snow, which would sit there and wait, falls as rain and runs off immediately. And that displaces water out of the reservoir, and that water eventually is lost out ultimately into the Pacific Ocean.
One of the primary sources of snowmelt runoff for the Los Angeles region is the Colorado River Basin. Since 2002, the demand for water has increasingly exceeded the river's supply. This gap is projected to continue to grow. One surprising reason: dust.
I was climbing a peak in Colorado with my father and my brother, and we dug out an area, just scraped dust off of the snow surface, and it exposed clean snow. We came back later in the day, we could see just this column of clean snow. All the dirty snow had melted down away from it, and it had melted less during that day.
It has melted less because clean white snow reflects more of the sunlight and heats up more slowly. The dirty snow absorbs more sunlight and melts faster. The grazing of cattle and sheep, and more recently, all-terrain vehicles stir up the dust. Today, vast areas of the Rockies are covered by dust.
So the dust causes the snowpack to melt faster and causes that water to get into the rivers faster and causes the rivers to rise faster. That made me realize, looking at the whole landscape, this is a huge water resource impact. The amazing thing about working at the Jet Propulsion Laboratory is that we can pick and choose technologies that have been developed for Earth missions as well as missions that are exploring the solar system. I'm the principal investigator on a new technology that we're developing here, and it's the combination of technologies on an airplane, and it's called the Airborne Snow Observatory. In the coming decade, NASA and JPL have spaceborne missions and airborne missions that will allow us to understand the global and regional water supplies.
Researching, modeling, forecasting, and analyzing the forces that affect hurricanes, earthquakes, and freshwater availability are just some of the ways that NASA helps us understand our ever-changing world. From the land, from the air, and from space, NASA, together with agencies and researchers around the globe, is working to make us safer on this planet we call home.